I'm here to present a paper on fraud shield, that is protecting transactions with machine learning models so that it will try to detect the frauds. And that we are applying this machine learning models here. And coming to this thing, as we are in the daily scenario, today's scenario, we are saying that many fraud tools are coming into light, like when we are using any credit cards, related to credit cards, and wherever we go, we are trying just to pay through UPI, that is cardless or cashless transactions are being done. And in these cashless transactions, as they are increasing a lot, the frauds are also increasing on the same basis. And here, by using this machine learning methods, we are trying to detect the fraud transactions that are being done. So here we can see that this is a growing trend in the financial area for both banks as well as customers. And if we see these frauds, what are the frauds done? One of them is synthetic identity fraud, which is trying to mix up the original details with the fraud details, and they are trying to make it as if it is clear one and it is clean one. And the other one which we have seen is something like shimming. They are trying to grasp the details of the original cards, and they are using those details to perform the fraud and to get the cash. Here they are saying that these frauds, they will just result in some loss in billions, financially loss in billions by 2030. So I thought this one is an emerging problem, and some of them already have solved it. But let me just give a try in this thing using machine learning. So here, the fraudulent, it is very difficult actually. It is very complicated to identify which one is fraud and which one is genuine. And the other thing is, so this presentation will cover the machine and models, what are the different models applied, and which one I have used for my experiment. So here, credit card involves, this fraud involves unauthorized transactions, and there is rapid increase, and we are also trying here, I need to identify the pattern related to the fraud one and the pattern which is related to genuine one. So by just identifying it, I can just detect the fraud that is going on there. And one major challenge, whenever we are doing any kind of research, we come across some challenges, and the challenge which we have come across here is related to class imbalance. Now if I am teaching the machine to identify some things, I need to give major kind of possibilities. Coming to my case, that is credit card fraud detection. Here I need to specify which one is fraud and which one is not fraud, or which one is genuine. So if I just let it learn the fraud kind of pattern, then it will try to identify in the next case right. But the thing here is everything is turning new, and everything is emerging new. Now, different kinds of frauds are coming into the scene, and this machine should be able to identify those new things, which is very difficult and very complicated. And one more thing is class imbalance. I already told you there are few things which are related to fraud transactions. Only few fraud transactions. The data set which I have taken is from Kaggle, which is available online, and there I have seen that there are 2 lakhs of records, among which only 400 records are fraudulent. So very less number of records are available for this thing, which was very difficult for us. So what I had to do is, I had to pre-process this thing, and the fields even were anonymous there. The fields in the data set were anonymous there. So what we have done is only time, that is the last transaction, when was the last transaction done, and what amount was taken, that was just given there, and the other fields were just anonymous because they should not be disclosed to all of them. In that way, the data set was present, and we took all those things, and here through oversampling and undersampling. Oversampling techniques will try to just increase minority things, that is fraudulent records or less. They have increased fraudulent records, and undersampling is if genuine records were more, they were just lessened. By lessening, we have problem actually by minimizing these things. When we minimize things, some of the information might be lost, important information might be lost, which we were able to control a bit smaller to some extent. And coming to the other thing, fraudulent things were increased. So that the machine will learn both the patterns related to fraud as well as the genuine one. So here we have applied some things like supervised machine learning and the other thing, relationship trees, neural networks. Coming to the case of supervised machine learning, SVMs were applied. SVMs, they have found out its boundaries. They have found out the boundaries for this for detecting fraud, and neural networks was also working with for identifying the intrinsic patterns, which is very essential for frauds. And the other one is ensemble methods. Coming to the case of ensemble methods, what happens there is you try to you try to make the weaker ones into stronger ones, convert weaker ones into stronger ones, where the fraud detection was low, and later on by combining and by solving this problem, by just improving its strength, they were able to identify. But here, a holistic approach is needed, and even transparency is needed, which is compliant in financial institutions. Because without the transparency and without the computation lightweight nature, this fraud detection will become difficult when any other new cases are coming, and moreover, training these things. Taking the case of neural networks, it takes a lot of time to train the system. So to avoid all these things and to go with holistic approach, we have used this logistic regression, and this in this thing for data acquisition, pre-processing. Whatever null values are there, also 6 were removed. And pre-processing, we have done cleaning of data, normalizing the memory values. And coming to the feature engineering step, we just try to get into a good quality input. So that if quality input is given, the output will also be fine or good. And this will ensure better model accuracy and generalization. I said to you that the previous things, they were accurate, but if any other new things are coming, training time is taking more and all these things, we had gone for logistic regression. So coming to this, I also told about this sampling and oversampling and undersampling. They were just increased, and to actually identify the patterns of fraud, the fraud records were also increased. And coming to logistic regression, here the model outputs the probabilities indicating fraud likelihood, and performance was also evaluated through accuracy, precision, recall, and reference score. Here we paid attention for recall because we need to find out the actual fraud records. Actual fraud records will find out using the recall, and through this, whichever fraud things have will go undetected will be detected, and this fraud will be minimized, and we are trying to mitigate the risk. And coming to the conclusion, so for effective fraud detection, we can use this machine learning models, and as I told you, I have used this logistic regression for performing this thing. And coming to the future work, we can even add some kind of anomaly detection algorithms, wherein different forms of artificial intelligence may be used, or different types of forest or random forest or vegetation trees may also be included there. So this is my article. Thank you for giving me this opportunity.
But my question is one thing. Nowadays, the previous cancer.
I've got a period of making a paper.
Silence.
So I'm presenting this article on behalf of
my students because they were handling the session. The most common problems that the civilians of India is facing is diabetic retinopathy. The patients, the diabetic patients may lose their vision due to this problem. Whereas our article, what is the theme of the article is we are getting images of diabetic patients from CAGI. After that, we are going for evaluation. So after evaluation, we can conclude that whether the patients have diabetic retinopathy or not. Since if the patient have diabetic retinopathy, then the precautionary measures will be recommended by the doctor to the patients. Here the methodology is we are taking the images checked from the CAGI and we are processing those images with CNN and recurrent neural networks. So after going for thorough analysis, we are able to extract whether the patient have diabetes or not. Basically, mostly we are using two algorithms. One is recurrent algorithm. The recurrent algorithm is mainly used for feature extraction. So we are extracting the features of the patients like to have diabetes. After that, after the analysis by using CNN, we are using RNN, recurrent neural network algorithm, to transform the input data to output data. So this is the basic model where we can go for the analysis so that whether the patient have diabetes or not. They are going for the optimization. As a part of conclusion, since we are using only two algorithms, but there may be so many algorithms which will give better results and better accuracy. So we have not gone for the comparison of existing algorithms with the other algorithms. In future, we can go for the analysis by using other algorithms also. This is our presentation. Thank you for giving me this opportunity. Thank you.
Thank you, sir.
Now I request Dr. Pramila Rani Madam from Aditya University, Patna. Now I request Sri K. Teja from ARC Systems, New Delhi. we break this session and we'll have session once again at 2 p.m. Thank you. So